Alright, in this one we're going to build a leaf shredder. This is going to go in front of our leaf vacuum that we've been making. If you haven't seen that video, go watch that video. It'll give you a better idea of what's coming next. This was a really fun build. We've always wanted to build something kind of like a hammer mill. Medium difficulty. The rotor was kind of difficult to build, but it was a whole lot of fun and the turnout was awesome. If you guys don't want to see the build, you can skip to the end and you'll be able to see us run it. Super cool. Stick around. I'm going to clean all these plates up. And I'm going to weld the flange on both sides. Maybe you can get a better idea. I put the shaft in there, so the bearing will be on this side. The bearing will be on this side, and this will rotate with all of the hammers and rotors in it. And then we're going to attach an output on one side of this to where it'll be sucked into the blower. That way it's getting shredded and then it's going through the blower instead of the other way around. Bearings we'll use. So we had this Kohler motor we were going to use, but we decided to upgrade and go for a bigger one. This is a 3-cylinder Kubota engine off an old lawnmower. We're going to see if it runs before we commit to it, but we'll use that for our shredder. I think it'll work a little bit better under load. So let's get to it.
Yeah, it is actually.
It's like just as heavy as that one.
Dang neared it. Dang neared it.
Woo! Woo!
Oh no, I got dirty.
Oh my gosh.
Heave-ho, heave-ho. Okay, so we want to mount that kind of like that. So I think we'll just run an angle iron down, then we'll just make another angle. We'll basically make a box around it. Which way do we want that thing to spin before we mount this?
My thought was that it would spin like if it's inputting this way, that they would come and sling it down.
Okay.
So it'd spin this way.
Okay.
So we're gonna cut out some angle iron in order to make a motor mount for this, a frame. And the way we're gonna do this is we're gonna have a clutch system where the motor gets raised by a lever in order to engage the belts. That way we're not starting under the entire load of the rotors that'll be in the shredder. Went ahead and got this new shaft rather than the other one. This is 1.5 inches, so it'll fit our bearings. I'm gonna cut it to 36 inches. That way I'll have space for the pulley, bearing, rotors, and the other bearing on the other side. That'll be our shaft.
I don't know what to do here.
Here we're determining the spacing between the rotors and how many rotors we can actually fit into our pipe. Make sure you take your time while you're doing this. Get out a pencil and paper and make sure it all maths out before you commit to building a rotor. Because trust me, you don't want to build a whole rotor and then be wrong or off by an inch. And you got to either make a new housing or change your entire rotor. But here's how we're going to set up the blades. We're going to do 1 with spacers in between it, and then do 2 with spacers in them, and just keep alternating that pattern. And then on the next one we stagger it, and we'll do that for all 4. So 1, 2, 3, 4. That'll be around the rotor. That way it'll all be evenly balanced. This is what our rotors are going to look like. We're going to have 1.5 inches to fit our shaft, and then we're going to have 8 holes around it Every other one will just have a shaft through it for support, and it won't have any hammers that swing on it. It'd be 7 5/8 as far as the outside. Let's go cut them out. While I went to cut those out, Scott made a frame for the motor. That way we can mount it on top of the shredder. Well, here's the rotor. Not as big as we'd like, but we're limited by lathe and how big of a rotor we can fit in the lathe, because we want to make sure we true it up so it's balanced. So we have to stick with a smaller rotor and use longer knives. This is only about 7 5/8 across. Yeah, give me the rundown. What are you doing right now?
We're going to see if this motor runs. It's been sitting over there for 10 years at least. So we're going to wire it all up, put some fuel to it, and see if it'll fire up. I like that.
Oh, look at that. That's fancy.
Yeah.
Fancy for us.
Yeah. When I scrounge something, I scrounge it all. Got Clark Griswold here working on the Christmas lights.
Oh yeah.
Okay, some fuel to it. This is the fuel pump. Let's see if that comes on with the key. Sure does. Okay.
IV bag for fuel. So we got this hooked up. This is your return line for the fuel. Runs back into IV bag, down the hose into the fuel pump.
We're getting there. Getting some fuel up there.
Ether time.
Yep. Ether, it'll start or it won't. Now we got to come up with a radiator. This was what heated my shop. I ran the hot water through it and had a fan behind it. Unless you want to bring one of them other ones down there, but they're too big too.
Yeah. You steal the radiator off this other one.
Oh, there we go. So we get another one.
So you get another gas one for it. Brand new. If you want to do that.
Does it have anything in it?
Well, it's empty completely.
Hmm.
I mean, this is pretty much very similar motor, size motor.
It is the same block.
Yeah.
It's just that one's got a different head on it.
Yeah. This one's for natural gas. Which we will get this running at some point.
I think that would work.
Yeah. This guy's insane. Remembers where everything is, despite...
I remember, I just looked in my scrap. I got the fitting that used to be in that radiator when it heated my shop, and they're 1 inch, and that's what size we need. So...
It's all falling into place. It's like it wants to be built. He's going to solder those back on there. I'm going to finish cutting out the rest of the rotors. We've all put it all together. Got the Harley muffler on it with the rain cap. That's sweet. And Scott put the radiator on, and we leak tested it and it works. So we'll use this engine for the shredder. Gonna be pretty freaking cool. Got the shaft clamped down. We're gonna center it up and drill a keyway.
Machine a keyway.
Machine a keyway.
Yes. Oh, look at that.
Beautifully milled. Beautifully milled.
Okay, well I guess we'll pull it out and see if it fits. If not, we'll put it back in there. And
Give it another run. Put it over.
this is another centering tool. Get your little dimple there. If we have to put it back in the machine, we'll set that up at 0, then we know we're parallel with the end mill.
What's the most useful tool you own?
Oh, I don't know. Good question. Welder.
Yeah, I guess that one kind of made you.
Use that a lot.
Yeah.
The iron worker, that's handy to have just to punch holes and shear stuff. We used to do all that with a drill and a bandsaw.
Yeah. So if you had to keep one machine between skid steer, any of that kind of stuff, which one? Just one. That's all you get.
Don't make me do it. I can't do it. I can't. Oh man, I'm gonna have to say the excavator, just for the simple fact that it has a thumb on it. That's like having your own hand. Maybe there'll be a tool out there that I don't have that I really need. How's that?
Oh, that's pretty good.
Curvedy curve. That's how we'll get the first one straight. Or do we want to just do that to all of them? Slide that down there, start here,
Oh yeah. Yeah.
work our way back.
I think if it works, that'd be easier than trying to screw with that everything else. This is just so we get our rotors straight up and down,
Perpendicular to the shaft.
perpendicular to the shaft. We're
That's
just
a
using
big word today.
using the bearing as a guide.
That's probably where this one needs to go. That just gives us a little bit of shaft hanging out. We got the thickness of our lid in there yet.
Everyone knows Jed Clampett. What does he do?
You really don't know Jed Clampett?
Jed Clampett. What? Well, movie guy?
Yeah,
What movie?
the Beverly Hillbilly.
Oh, okay. Mr. Clampett. I wonder if Mr. Clampett will watch this video.
You done did. I'm gonna tack them all on there. We'll get all the rods put in. Then we'll weld.
Tack it, move it, put the bearing there, and work our way all the way to the end. I'm gonna cut the rods that run through these holes here, the ones that will permanently be welded in there.
Smashed a little bit on the end. That's all right. We got a machine for that too.
What do you not have a machine for?
Time. When you shear, it creates a flat spot because it's got a flat die that's smashing it, and it kind of oblongs it a little bit, so I just knocked the high points off so it goes right through the hole now.
I want to quickly add that this is one of the most critical parts of this build. Since this thing will be spinning at high speeds, it's important that everything remains balanced. So we really spent our time making this rotor because we were concerned it was going to cause a lot of vibration in the finished product. What? Come on.
No.
That looks a little bit bigger than a 4-inch disc on there. Is it?
It's big. Stand back. Don't try this at home. It's the initial torque that's scary.
Yeah.
When
The initial spin up.
when it tries to take it out of you.
Anything spinning.
750. Pretty dang smooth.
Yeah, it is. You really see it when you go like this.
Plus, I'm going to go down through there and machine all that down so it's round.
And it's only missing by a little bit.
Yeah, I can take that much off of it.
Oh, yeah. Okay. Now it makes sense.
That's why I moved that down here.
Huh. That'll work. Okay, I can't be inside your head.
It would probably.
That's a scary place.
Scare you.
I don't want to be in there.
Most people would run.
I'd sign up for that.
It's still smooth though.
Oh yeah, that's nice.
That is really nice.
A bit of a relief.
I'll feel much better whenever that's inside a cage spinning.
Yeah.
Not in front of my face. So I'm gonna take it out, do all the welding, weld all them in. I'll put it back in here and then I'll
True it all up.
True it up, yes. We came in a little under 22 and a half, which is good. That'll fit in there.
It's a good looking piece.
Got a little twist in it, but for a prototype, I think it's gonna be just fine.
We chose to use stainless steel rods for this because we think they'll last a little bit longer, hold up a little bit better.
Then I got a bunch of them laying around.
Plug weld them in the end.
To weld the stainless to the mild, we'll use a 309 stainless welding rod so it doesn't crack.
This reminds me of those bubble plate distillers for distilling like vodka and whiskey and stuff like that. Pretty cool. Go see a video of those. Those are pretty cool to watch. I'm gonna go ahead and make the knives for it. We decided to put 66-inch knives on them. So we're gonna shear them all off and then we'll punch holes in them. Alright, got the jig all set up. This is a stop so that it only shears them off 6 inches. There it is. All 60 of them right there.
Okay, now we just need to build a jig to that.
Is this your biggest C-clamp?
I think so.
Nice.
Might have to open them up a little bit.
Got them all punched out. Got holes on either side. That way, when one side wears out, you can flip it to the other side and use the other side. So it doubles the life of each blade. We punched them all. We're gonna have to ream them out a little bit for them to fit. And they'll slide on like that.
It's much nicer.
Next thing we're going to do here is we're going to drill holes in all 4 of the rods that hold the hammers. This way we can put a cotter pin in it and we can remove it. And on the other side it's going to have a slug on the end that'll stop it. So they only come out one way with the cotter pin. There we go. Got all the holes in them. Now we're going to push these in a little bit and weld on the inside of that so it stays in place. So now the concept might make more sense to where this slides to each hole and then we put more hammers on it like this. We can slide it to the next hole. The point of this is that we can replace the hammers and take them in and out, put more on or less on, but I think we're going to do it like this where we have spacers that will go between these. And they'll all be spaced out and swing freely on the rods. So whenever this thing's spinning like it was on the lathe, these will be out straight and won't impact anything. Pretty cool. Here's what it will look like when one rod has all the hammers on it. We have it in an alternating pattern, 3, 2, 3, 2. And then we'll switch it so the next rod here will have 3, 2, so on. Yeah, looking really good so far. Pretty nice. Gonna hit them in a little bit. Put our weld in there. Yeah, it's insane. So this is what it looks like completed without the hammers on it. Next thing we're gonna do. Oh, what? Next thing we're gonna do is drill the holes for the bearings to fit on there, each lid.
What did I tell you? Okay, we're gonna punch them through this one, and then we're gonna put bolts in here to line everything up. We're gonna punch through these for the next one, so everything's in line.
Just get the other one.
Well, let me make sure I have this bolt through.
That thing is handy. The old petting hoss. Probably saying that wrong. It's like, is it Knipix? Or is it Nipix? Alright, so we spent a lot of time trying to figure out how we wanted to do these entry and exits on this pipe for the leaves will come in and they'll exit. We thought we were going to do a big slot across the top, and that way the leaves, we'd put dividers in there so they would fan out and use all of this. But we came up with a different idea. We're going to just put a pipe on one side, then a pipe for exit on the other side of it. That way the leaves have to enter, and they'll kind of have to swirl through a lot of the hammers in order to be pulled out. And we think that that's the best way to utilize all of the hammers and the rotor, rather than trying to exit this or enter this way and only hit some of them. They'll have to come in this way and be pulled by the air and then out. That way we get more retention time in there. We think that if we can do that and at least retain the leaves for a second, they'll get hit 80 times. Anyways, that's all maybe too complicated for this, but we're trying to increase the retention time that the leaves are in the grinding chamber. So we're going to offset the pipes. Simple enough. So now it's time for the hard part. We're going to try to find some 12-inch pipe. We're going to try to contour it and be able to cut it out and so that it'll fit on there. That's probably going to be harder than it seems.
That'd
be kind of hard.
That's a start.
Oh yeah.
It's weldable.
Very weldable.
I can beat that top down a little bit. Put the flange on that first.
And weld the flange to it.
So that should throw that down in there.
Alright, punched these holes out on this flange. We didn't want to cut it off and put a new one on there. So now we're going to do the same thing we did with the other pipe over there, but this will be the output side, so we're going to put it up here. Got that gummed on there. This is complete. We're gonna bolt this onto it there, and leaves will enter this way, get shredded, be sucked up by the fan and blown into a trailer. That's kind of what it'll look like. Guess that is what it'll look like.
That is what it is.
The problem we're facing here is that when we bolt this on here, it's at an angle, which means all of this will be tilted a little
I
bit.
don't have the flange clocked right with this flange.
Yeah, so we're gonna try to square it up by changing this stuff
Flip it
around.
over and try this one. But then we're getting farther away yet.
We're like real far away.
The old snuffleupagus.
I'm gonna take these bolts out, see if we can't rearrange all this. Now we'll modify that to fit this, hopefully level. So we noticed something with our fan, and it's that this part here is what's actually throwing it up, and we don't want it to be that. It should be like this smooth part here. So we're gonna pull this off, flip it around, and put it back on. That way the flat plates are actually what's throwing it up and out. Alright, got the shell of it off. We're gonna pull this out and see if we can get it off. So nothing short of a miracle. We got the set screws out of it. Now we have to find a way to pull it off of there. Yeah.
That looks much better. She's gonna be ripping and tearing to shreds.
So you can see now when it spins up, it's all the flat plates instead of this coming up. Alright, this is how it's going to look. I'm going to put legs under this. The other motor will sit on top of this. It's going to end up being a little bit tall, but it should still work. Yeah. Alright, we got the housing on there. We got the legs welded on. I'm going to go ahead and cap one side so we can put the rotor into it. Let's see what it looks like when it's almost all together. Look how cool that is, though.
Getting excited.
Like a, that's like steampunk or something.
Yeah.
Let's put this rotor in. Alright, so I lost some of the footage of the rotor being built, but basically what we did is we slid those rods in, added hammers and spacers along the way, and the spacers we used, you see there, are just pipe we cut to put in between them, so looks super cool.
Easy. Damn it, Bobby.
What's that, your wand? That?
I got my end picked up.
That's kind of what will be happening in there.
Except once it gets up to speed, they're gonna just straighten out. They're not gonna flop around like that. The only time they'll flop is on startup and shutdown.
And bend the cotter pins over so rods don't fall out. So it'll enter over there, make its way through all these hammers. The fan right there will suck it through there. And this whole shaft is spinning this way. It smacks it down and makes it come up and out.
Okay. That right there. That is gnarly.
Look at this thing. Spin the shaft. What does that look like?
Where it's going to have to be right about there. But we'll have to let them down to get them to loosen.
Yeah. Got the hinges there. Pried it up just like you did, and it tightens the belts up. That way we don't start it with all of it engaged and the starter's trying to start the engine, also turn the rotor at the same time. I'm going to put this on here. I'm going to tack it on there. It's just a squared around flange there, just for testing purposes. That way we don't blow leaves all over both of our engines. I put grease in both bearings on either side. I put gussets in on the hinge part here, so the whole motor will just hinge, and when it gets raised up, it'll tighten these belts up. Alright, here's where we're at. We ended to add a thimble to this, and yeah, we're just going to go ahead and try it and see what it's like.
We forgot to tighten the bearings. We're spinning on the shaft.
So how freaking cool is that? So awesome. The only thing we ran into here was that the belts were vibrating, which kind of caused the whole thing to vibrate. There's no motor mounts on the motor, so it's left just on a solid floor. But we'll see once we move it out and put it on soft ground, it's completely fine.
Damn, Carter, I just needed about a quarter in it. Damn. Woo.
Alright, we're going to set it over here and try and stick up this pile of leaves. Yeah. Fire that up. got power. We didn't change the pulley on it. I'm just gonna throw a bunch in it at once and see what it can do. I'll pile it all up, send it all through. That it? Yeah. This is way better though. Yeah. Yeah. Drag it along the. About to get showered.
Blow it all on the pile, then suck it back up like you suck it back out of the thing.
Yeah. It's definitely more tore up.
Yeah. You can try to find another smaller ship.
Yeah.
That thing ain't even bothering. I really thought we were going to struggle.
That didn't even make noise. It didn't stop the position. Or find another one and put it on there. So, but this thing doesn't even bog down at all. It just keeps running and running. Not enough speed, I guess? Not enough tip speed?
Probably not. Something fast as cold. That's probably great for weak mode.
Yeah.
Well, you know, we're going to suck it back at it soon, so it's going to get around again.
Go try without the pipe. There we go. That's a lot smaller than it was. That little pile and all of this is pretty much gone. We think if we could switch out the pulleys on it and make this pulley smaller, we'll get even more speed. But we're pretty happy with that. There it is, the Leaf Vulture Shredder. Thanks for watching, guys. We'll see you in the next one.